and today we are going to be looking at how to find distances between points in a coordinate plane. Yesterday we looked at how to plot polygons and how to connect the dots once you had your points plotted in the coordinate plane. So today we're going to take this one step further, and we're going to be looking at points and finding distances. So thinking about things like if I'm reading a map and I see a post office and a grocery store, like how far apart would they be? Those dots can represent the same exact thing. So we're going to first look at how. The formulas. So there's some formulas that we can use that would tell us how to find those things. So first thing we want to do is have our coordinate plane here. And my first two dots I would have, let's see here, 1, 2, -3, and then up 2, 1, 2. So there's one dot, and then the other one is at -6, 2. So I'm going to go 3, 4, 5, 6, and then up 2. So here are my two dots, and we want to know how far apart are these two dots from each other. And so there's a couple different ways we could do this. So first, you could just count. You could count 1 jump, 2 jumps, 3 jumps to get to here and see that they are 3 apart. So 3 apart just by counting the jumps that it takes to get from one to the other. Another way that we could look at this is to just determine, are they in the same quadrant or are they in different quadrants? So both of these points are in quadrant 2. So if the points are in the same quadrant, we are going to look at their ordered pairs. So let's talk about what we have going on here. So our first pair is A, and then the second point, is B. And we want to know how far apart are those two dots. Well, we could first look at point A. Well, point A, it has an ordered pair of -3, 2. Point B has the ordered pair of -6, 2. Because they're in the same quadrant, we would just look at the absolute value of the two numbers that are different. So look at the numbers that are different. Okay, so we have two x values. And what we would do with that is we're going to take this -3 and we would find the absolute value of -3. We would then find the absolute value of -6. Well, we know this one is 3 and this one is 6. You're then going to just subtract the smaller from the bigger. So we would go 6 minus 3, and that gives us, nope, just kidding, 3. So because you counted the points, or you could just subtract their absolute value of the ones that are different. If the y values were different, you would subtract the y values instead. So these points are 6 minus 3, which is 3 spots apart. Okay, if the points are in a different quadrant, so let's say that they are in a different quadrant. Okay, so if the points are in a different one, we're going to find them in different quadrants. Okay, we're going to look at these and put them differently. So the first, let's use a different color so that maybe you can see them over here. Okay, so my first one is at 2, negative 4. So I would go over 2 and then down 1, 2, 3, and 4. So here's 1. And let's call this point C. And then point D is at 2, positive 1. So over 2, up 1, there's point D. Okay? If you notice, they're in different quadrants, right? So we want to find the distance between here and here. Again, you could jump, making sure that you count the axis as a line. So you could count 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps to get from one to the other, just like on a number line. So looking at the difference from here to here, we can see when we jump, it's 5 jumps. Or you could also use absolute value. Okay, so we're going to look at absolute value of these ordered pairs. So the first ordered pair was point C. And point C was at ordered pair 2, 4, or 2, negative 4, excuse me. So 2, negative 4. D is at 2, positive 1. And so our job would be to find, again, the absolute value of each of those numbers. So we're going to find the absolute value of negative 4 because that is the one that's different. The 2 is the same, so we're not worried about that. We're worried about the difference here between these two numbers. So we're going to find the absolute value of 4, which is 4, and the absolute value of 1, which is 1. And now we're going to add. Okay, so we're going to add these ones instead. So if they're in different quadrants, we add, and we get 5 jumps. If they are in the same, you're going to subtract. Okay, so different equals adding. Same equals subtracting. Same, subtract, different, addition. Okay? But what does this actually look like when we're graphing? So these were just kind of the rules. So get those rules down, and now I'm going to show you what it looks like in action. Okay? So let's do some examples of these types of problems. So again, if you're comfortable just counting the jumps, just count the jumps. But they don't always give you like graph paper or show you. Sometimes they have you find the difference when they just give you the ordered pairs. At that point, you could graph them and then count if you wanted to. Or not. It's totally up to you how you want to solve these and what you're most comfortable with. But I am going to show you how to do it when we're given some graph paper and they are graphed in. Not that one. That was awful. Okay, let's try again. This one's not any better. Oh my goodness. I really need graph paper that has the lines already made. Okay, so let's do example A. Okay, so here's example A. Example A wants you to find the distance between negative 3, 5 negative 3, negative 5, and 2, negative 5. Okay, so you could just right away, without looking at the graph, you could find the absolute value. But let's go ahead and determine where these points are. So we're going to go to negative 3, negative 5. So over to negative 3, 1, 2, 3, and down to negative 5, 1, 2, 3, 4, and 5. So there is one dot. Over to 2, and then down to negative 5. And here we have both of those points listed. Okay, so they want to know what is the distance between those points. So they are in different quadrants. Because they're in different quadrants, we're going to look at the ones that are different. Here's the one that is different. So we're looking at the absolute value of negative 3, which is 3, and the absolute value of 2, which is 2. We know that they're in different quadrants. So because they're in different quadrants, it tells us to add them. So we're going to add. And this gives us, again, 5 jumps. I can also come over here and I could just count how many jumps it takes to get from one to the other. So negative 3, negative 5 is the first one. So I'm going to jump. 1, 2, 3 jumps here, 4, and 5. So it took a total of 5 jumps. This looks like a person with hair right now. Okay, let's do another example. Okay, so we're going to do example B. And example B wants you to find the distance between three, negative 1, and 3, negative 5. Okay, so it wants you to find the distance between those 2 points. So again, we're going to start out first by looking at the ones that are different. Okay. Now we're going to have to determine, are they in the same quadrant or are they in a different quadrant? You can determine if they're in the same quadrant by looking at their values. Okay, so they both have a positive and then a negative. That means that they would both be in the same quadrants. Or we could just graph. Going over to 3, 1, 2, 3, and then down to negative 1. Over to 3, 1, 2, 3, and then down to 5, 1, 2, 3, 4, negative 5. And we want to know the distance between these two. So again, we can take the absolute value of negative 1 and the absolute value of negative 5. And because they're in the same quadrant, same says to subtract. So we're going to subtract the points. So 1 minus 5, but we need to flip them because the smaller number needs to come first. So it's really, second. 5 minus 1, which equals 4. So now we're just going to count those jumps. How many jumps does it take? 1, 2, 3, and 4. it took 4 jumps. So you can use any method that you like in order to jump between the points. Okay, so I'm going to turn my page right now, and I'm going to do another example with you, just so that you have one more. I wish I could have fit it on that page, but that's okay. All right, so let's look at example C. So example C says to find the distance between the first one is negative 4.5, so we're getting a half in there, which is good. We need a half. And negative 5. And then the second one is, oh, no, I'm sorry. Negative 4.5, 2. This should be, oh, let's just rewrite this so that it's not so sloppy. Okay. Negative 4.5, 2. There we go. And the next one is negative 7, 2. Negative 7, 2. Okay, so sometimes, like I said, they will just give you this, and your job is to determine if they're in the same quadrant or not. So these ones would be in the same quadrant because it's a negative, positive, right? So we know that this is a negative, this is a positive. This is a negative, this is a positive. Those are the same quadrants. When we look back at, let's do this one. This one was a different quadrant because this one, negative 3, 5, is a negative, negative. This one is a positive, negative. And so you can see that they're in different quadrants because they're not the same types of numbers. Again, this one was positive, negative, positive, negative. So they're in the same quadrant. Okay, so here we could graph it, or we can just look at how to solve it without graphing. And I think I'll do that for this one, just so you can see how to do that. So our first step was to determine which one is different. The 2 is the same. So we're going to look at the negative 7 and the negative 4.5. These are in the same quadrant. So that means we're going to be subtracting the smaller from the bigger. Okay, so let's first start out by looking at negative 4.5. We're going to put that into absolute value. And that gives us negative 4.5. Positive 4.5. Oh my goodness, how many mistakes am I going to make? The next one is negative 7, and we're looking at the absolute value of that. And so the absolute value of that is a positive 7. So our job, if they're in the same means 2. If we look back at our notes, we determined same quadrant means subtraction. So we're going to subtract, but we need the smaller number to come second. So really we're doing 7 minus 4.5. Okay, so we have a half number here. So it takes a half to get to 5, right? So if I add a half, that gets me to 5, and then I have 2 more after that. So I have 2.5. That is how many jumps it takes. We can now look at this on a coordinate plane and double check our work if you wanted to. So if you wanted to make sure that you had done this correctly, you could just graph it yourself. You have access to sticky notes. If you don't want to use up all your stickies, you can use a Jamboard. A Jamboard would also help you see it. All right, so we've got negative 4.5, 2. So here's a half, Here's 1. Here's a half. Here's 2. Here's a half. Here's 3. 3 and a half. 4. 4 and a half. And then we want to go up 2. So up half. Here's 1. 1 and a half. Oops. 2. All right, so there is our first point. So each of these lines now has turned into a half of a line instead of a whole line because of the half that we have. The next one is -7, 2. Oh no, I don't have enough. I don't have enough. I don't have enough lines. Okay, let's do this instead because yours is going to do the exact same thing. Let's just count in between each box is going to be a half. So you would make your own. Okay, so from 0, 0, we're going to go to -4 and a half. So from here, so there's 1, 2, 3, and 4. And 4 is not to 5, it's right here. And then we will go up 2. So 1, 2. So your dot is actually in between the two lines. It's halfway. Okay, same thing with the next one. We're going to go over to 7. So 1, 2, 3, 4, 5, 6, 7. And then up to 2. Okay, same quadrant. We're going to subtract or we're just going to count the difference. So from here to here is 1. Here to here is 2, and then we go one little spot right there, so that is why it's a half. So 2.5. I'm sorry that one was so crazy. On your big ideas, it will be a lot neater to look at than on your graph paper. Okay, let's go ahead and do some triads right now. So I have a triad for you. There we go. All right, your triads for today. I would like for you to please find the distance between. So find the distance between. We have triad number 1. It says -6, 6, and -2, 6. And then the distance between on number 2, it says -4, 2, and -4, -5. Okay, so go ahead and hit pause right now so you don't hear me solving these, and then hit play when you are ready. So again, we're just going to look at the absolute value of the ones that are different. So here, this one's different, and this one's different. This is a negative, positive, negative, positive. So they are in the same quadrant. Same quadrant means to subtract. So we're going to take the absolute value of -6, which equals 6, the absolute value of -2, which equals 2, and we're just going to subtract them. 6 minus 2, and that gives you 4. 4 jumps. All right, on this problem, again, we have a positive, negative, positive, and a negative, negative. Okay, so these are different. They're different quadrants, and so that means that we are going to be adding. All right, so we have the absolute value of the ones that are different. So this one is 2, which gives us 2, and the absolute value of -5, which is 5. We're just going to add those, 2 plus 5, and you get 7. If you were to graph both of these, you could see that they are 7 jumps apart, and 4 jumps apart. So you have different ways of being able to solve both of those. All right, go ahead and answer your essential question. How do you find the distance between points on a coordinate plane? And then rate your level of understanding out to the side. When you are finished, you may come back to the Google Meet and ask for help if you need it, or more examples, or you can head on off to do your practice work. As always, I appreciate all of your hard work, and make it a great day.